So hello guys, welcome to my YouTube channel Med School with Shubham. I am Shubham, a third professional MBBS student, and I shall be teaching you anatomy. I have started a new series on embryology on my YouTube channel, in which I have completed the first week of development, second week of development, and the third week of development. And today we will be starting with the further developments of the embryo, in which today we will be learning about the mesodermal differentiation in the embryo. So as we all know that this is a embryonic plate or embryonic disc or a trilaminar germ disc. It is a trilaminar germ disc. Trilaminar germ disc. In the previous lecture, we learned about the formation of the trilaminar germ disc from the bilaminar germ disc, and this process was called as the gastrulation. So now we have got a trilaminar germ disc. What does trilaminar germ disc mean? Tri means three, laminar means layer, and germ disc means a disc made up of three germ layers. So trilaminar germ disc means a disc which is made up of three germ layers, that is the ectoderm, mesoderm, and the endoderm. So let's name them. This red color one, which is on the most upper side, is the ectoderm. Then this yellow color one, which you can see here, is in the middle, therefore it's called as mesoderm. And this green color one, which is on the base side, it is the endoderm. I hope you understood this. So this is the ectoderm. In the middle we have the mesoderm, and in the base we have the endoderm. Now I shall be cutting this trilaminar germ disc in this manner, and when I cut this in this manner, I can see a structure in this way. Okay, see, I have cut in this manner, and then I will get a structure in this way. In this also, the upper is the ectoderm, in the middle we have the mesoderm, and in the base we have the endoderm. Okay, and in the center we have this which is called as the neural tube. So this neural tube, it runs in this manner, and below the neural tube here you can see the notochord. Okay, I hope you have watched my previous lectures. Guys, if you have not watched my previous lectures, I request you, please go on my YouTube channel and watch my previous lectures of the embryology, so that all your concepts regarding embryology will be very clear. So this is the neural tube and this is the notochord. Now what will happen further? Inside the mesoderm, you can see thickenings of the mesoderm. Means what? This embryon trilaminar germ disc will now become, you can see some thickenings inside this in this manner, like this. Okay, so you can see some groove formation. These are grooves. Instead of being a straight line, it will become elevation and depression, in this form. Okay, now it will look something like this. See, it was first a plain disc. Now some elevation, depression can be seen. Elevation, depression, just like similar to the gyri and sulci in the brain. You can see the elevation over here and a depression over here. Elevation over here and a depression over here. So you can, and these are the grooves. Okay. Now these are the mesodermal thickenings. You can see here. These are the mesodermal thickenings, and based on the position of the mesodermal thickening, we can name them. So this middle one is the neural tube, and this is the notochord. Now that mesodermal thickening which is on the lateral side of the neural tube, means this one which is on the immediate lateral side of the neural tube, it is called as the para-axial mesoderm. Para-axial mesoderm. derm. Okay. Then lateral to the paraaxial mesoderm means this one. We call it as the intermediate mesoderm. Intermediate mesoderm. The paraaxial mesoderm, the intermediate mesoderm, and the most lateral one, this one, it is called as the lateral plate mesoderm. Okay, so this is the paraaxial mesoderm, this one is the intermediate mesoderm, and this one is the lateral plate mesoderm. Okay, I hope this is very clear to you guys. Now this paraaxial mesoderm, intermediate mesoderm, and the lateral plate mesoderm will give rise to certain structures which we will be learning now. The paraaxial mesoderm will give rise to a structure which is called as the somites. Okay, the intermediate mesoderm will give rise to the entire urogenital system. The intermediate mesoderm, it gives rise to the entire urogenital system, and lateral plate mesoderm also gives rise to many things. We will be learning it separately as a lateral plate mesoderm topic. So first we will take the topic which is the paraaxial mesoderm. So where is the paraaxial mesoderm present? It is present on the immediate lateral side of the neural tube, or the either side of the neural tube. So it runs in this way. Here in the middle you have the neural tube, and on the immediate lateral side of the neural tube you have the paraaxial mesoderm. So let's take a new page. Axial. Okay. Paraaxial mesoderm. So what is paraaxial mesoderm? So paraaxial mesoderm are thickenings of the mesoderm which are present on the lateral side or the either side of the neural tube. Mesodermal thickenings. Paraaxial mesoderm are what? Mesodermal thickenings on the either side of the neural tube. Okay. Now this paraaxial mesoderm will give rise to a structure which is called as somite. It forms. Now paraaxial mesoderm will form the somites. Okay. It will give rise to somites. So what are somites actually? So for that let's make another diagram. Assume that this is the neural tube. Okay. Now I am watching it from the above. I have cut this thing. Okay. I have cut this in this manner, in this plane. Okay. I have removed the upper part, and now I will see it from the above side. Okay. So now this is the neural tube. Then beside to the neural tube we will see the paraaxial mesoderm. Here this is the entire paraaxial mesoderm. Now what happens? The paraaxial mesoderm becomes even more thickened, and it will be formed in a form of small balls. Small ball-like structure or a series of ball-like structures are formed along on the either side of the neural tube in this way. Okay, and this is the remaining paraaxial mesoderm. These ball-like structures are called as somites. Okay. So what is the definition of somites? So thickening of the paraaxial mesoderm that forms ball-like condensation on the either side of the neural tube is called as somites. So what are somites? Somites are also thickening of the paraaxial mesoderm. Thickening of paraaxial mesoderm, which forms ball-like condensation. Ball-like condensation or ball-like structures on the either side of neural tube. On the either side of the neural tube is called as paraaxial mesoderm, is called as the somites. Okay. Now these somites will give rise to various structures in the body. Now we will study about the derivatives of the somites, that what structures the somites will be giving. Somites. Let's first study about the somites, some important things about the somites. So somites, it starts appearing on the day 20, and it will be appearing till day 30. Means the production of the somites, the formation of the somites will start on the day 20 and it will end on the day or it will run till the day 30. The next thing are how many somites are present. So initially there are 42 to 44 pairs of somites. Initially there are 42 to 44 pairs of somites. So what are they? So first we have the pre-occipital somites, then we have the occipital somites, pre-occipital somites, then we have the occipital somites, then we have the cervical somites, pre-occipital, occipital, then we have the cervical, then we have the thoracic. After thoracic we have the lumbar, sacral and coccygeal. So pre-occipital there are roughly around 2 somites. In the occipital region we have 4 somites. In the cervical region we have 8 somites. In the thoracic region we have 12 somites. In the lumbar region we have 5 somites. Sacral we have 5 and coccygeal we have some book says there are 5 somites, some book says there are 8 somites. So let's take a rough approximation that there are 8 somites. Okay. Now let's count all of this. So 2, 4, 6, 12, 24. So it approximately comes out to be 44, approximately 44 pairs of somites. These are the 44 pairs of somites. Okay. Means on one side of the neural tube there will be 44 somites and on the other side of the neural tube there will be 44 somites. I hope this is correct. Okay. There might be 44 or even 1 or 2 might be more or might be less than 44 somites. Now what will happen? 1 from the cervical somite and 2 from the coccygeal somites. 1 or 2 from the cervical somites and 1 or 2 from the coccygeal somites will get degenerated, and then after that, after degeneration of some somites, now the total number of somites will be 37 pairs of somites. Initially there were 42 to 44 pairs of somites. After degeneration of some somites, there will be now 37 pairs of somites. Means from cervical 2 somites will get disappeared, and from coccygeal 3 to 4 somites will get disappeared. So overall the number comes out to be 37 pairs of somites. Okay. Now let's learn about the derivatives of the somites. Now these somites are further divided into 3 parts. The first is the myotome, then we have the dermatome, and we have the sclerotome. Somites are further divided into myotome, dermatome and sclerotome. Means a single somite will have myotome, dermatome and the sclerotome. Let me draw this here. So might be this is the myotome, this is the myotome, this is the dermatome, this is the sclerotome. In this way, three types will be there inside the somites, or three parts of the somites will be there. Now, according to name, you can guess the structures that will be deriving from the somites. So the myotome will be giving rise to the muscles. But which muscles? The skeletal muscles. Skeletal muscles. The dermatome will give rise to the dermis of the skin. Dermis of the skin. But some book says that the dermis will be formed only in the skin of the back. Only in the dermis of the back skin. And sclerotome will give rise to the axial skeleton. Axial skeleton. What does axial skeleton means? The ribs plus vertebrae. Okay. So these are the derivatives of the somites. So there are three parts of the somites: myotome, dermatome and the sclerotome. The myotome will give rise to the skeletal muscles. The dermatome will give rise to the dermis of the skin, mostly of the back region. And the sclerotome will give rise to the axial skeleton, which includes the ribs and the vertebrae. Okay. Now let's move forward. Now we saw one more very important thing, that this myotome and the dermatome, both of these parts are being supplied by the single spinal nerve. Single spinal nerve supplies this dermatome and the myotome. Therefore, some authors also they include the dermatome and the myotome under a single heading, and they name it as the derma-myotome. Okay. So what did I say? Again, let's repeat it once again. Somites are divided into three types. Somites have three parts: the myotome, the dermatome and the sclerotome. The myotome will give rise to the skeletal muscle. Dermatome will give rise to the dermis of the skin, mostly of the back region, and the sclerotome will give rise to the axial skeleton, which includes the ribs and the vertebrae. Now, the myotome and the dermatome are being innervated by a single spinal nerve. Therefore, they are collectively called as the derma-myotome. Okay. So this ends the somites part. I said that the intermediate mesoderm, let's write that. Intermediate mesoderm, it will give rise to the urogenital system. The entire urogenital system will be formed from the intermediate mesoderm. So what does urogenital system includes? The kidneys, the ureter, the urinary bladders, and the testis, ovary, and the urethra, and then you will get the uterus. All these things will be formed from the urogenital system. Next we have the lateral plate mesoderm. Lateral plate mesoderm. Okay. Now, this lateral plate mesoderm, let me draw the same diagram once again. This one. What happens? In the lateral plate mesoderm, a new coelom is formed in this way. In both the lateral plate mesoderm, a coelom will be formed along the lateral plate mesoderm. I hope you understood. See, this was the entire embryonic disc. We got the paraaxial mesoderm. Then we got the intermediate mesoderm, and we have now the lateral plate mesoderm. Inside the lateral plate mesoderm, within the lateral plate mesoderm, you will have a coelom, and this coelom is present within the embryo. Therefore, this coelom will be called as the intra-embryonic coelom. In the second week of development, we learnt about the extra-embryonic coelom because it was outside the embryo or outside the bilaminar germ disc. But this is present inside the germ disc. Therefore, it is called as intra-embryonic coelom. So let's draw the diagram for that now. So this is the ectoderm, not the epiblast, ectoderm. Then you have this endoderm, and in the center you have the mesoderm. But now I have cut this diagram, or I have taken the section in this part only, in this part. So I will be watching it from let me explain you in the form of this. Assume that this is the embryonic plate or embryonic disc. In the middle you have the neural tube. Okay, now immediately on the either side of the neural tube you have the paraxial mesoderm. Then beside that you have the intermediate mesoderm, and beside that you have the lateral plate mesoderm. Okay, now when you view the diagram in this manner, okay, now in this you can see, okay, in this way. Now in this you can see this is the neural tube. Beside that you have the paraxial mesoderm, then you have the intermediate mesoderm, and the most lateral one is the lateral plate mesoderm. The same diagram, see, first I was holding in this way, when you can see the lateral neural tube in this way. But when I change the view, you can see the lateral neural tube over here. Now what will I do? This is the lateral plate mesoderm. I hope you know this is the lateral plate mesoderm, which is on the most lateral side. And I said that the lateral plate mesoderm will be having a coelom inside that. Now I shall be drawing the diagram in this manner. Okay. Now what is this? The above one is the ectoderm, the below one is the endoderm, and the middle one is the lateral plate mesoderm. Okay. So in this diagram you can, when in this view, you can see all the three types of mesoderm along with the neural tube. But when I change the view, in this view now, you can only see the ectoderm, you can only see the endoderm, and in the middle you can only see the lateral plate mesoderm and not anything other else, or the, like paraxial mesoderm. You won't see that, only you can see the lateral plate mesoderm. And in the center you have this coelom. This coelom, you can see this coelom also. I hope you can see this coelom in the middle. So this is the intra-embryonic coelom. Okay. So let's draw that thing. I will be cutting in this manner. Or let's finally draw that thing first. Okay. So this was the ectoderm. This is the endoderm. This is the endoderm. And in the center you have this lateral plate mesoderm. Okay. Okay, so let's name the rest thing. This is the lateral plate mesoderm, this thing. Okay, and in the center you have this one, you have this intra-embryonic mesoderm. Okay, you have the lateral plate mesoderm. This one, the entire thing is the lateral plate mesoderm. And the middle coelom you have, oh sorry, it's my mistake, it is the So let's draw the diagram now.